Okay, the fourth unit we covered was elements, compounds, mixtures, so we worked on comparing and contrasting those three things. We also looked at how to separate them, so there were 4 methods of separation. It says match each term with its definition. So the first one says element. An element is a pure substance that cannot be separated into a simpler substance. So that should be C. A pure substance is just a substance with only one kind of particle. A metal is shiny and conducts heat and electricity, so it's a good conductor. A metalloid has properties of both metals and nonmetals. Nonmetals do not conduct heat or electricity, and they should be dull. The difference between an atom and an element. So atoms are the smallest unit of matter. They're what makes up matter, something that takes up or has mass and takes up space. An element is just a specific type of atom. So it has a specific number of protons, neutrons, and electrons, which is what we learn in 2 chapters from this one. So like carbon, hydrogen, oxygen, nitrogen, they're all specific elements, but they're also atoms. In this one, I'm just going to highlight, this was a foldable from our note packet. So we had, are elements a pure substance? We would say yes. Do they have a ratio? No, because you can't compare. Can they be broken down? No, because they're the smallest unit of matter. They have one element, and what are they classified into? They have 3 categories, and those were listed on this other page. We have metals, nonmetals, and metalloids. And the characteristics of metals would be that they're shiny, they're good conductors of heat and electricity. Nonmetals are dull, they are bad conductors of heat and electricity, they tend to be brittle. And characteristics of metalloids would just be any 2 properties of metals and nonmetals. Then we're going to jump over to the other side where we're looking at compounds. Are compounds a pure substance? Yes. Do they have a specific ratio? Yes, because you can compare the 2 different elements to each other. Can they be broken down? Yes, and how? So they can be broken down in 2 ways. You can either use heat or an electric current. They are made of 2 or more elements, and they have different properties than each element. And in the both section, are they both pure substance? Yes, they are both made of particles called, you could say, either atoms or elements. And they can both be identified by their properties. So chemical properties and physical properties both help us identify elements and compounds. And this was a threefold, so these are comparing the 3 different types of mixtures that we had. Solutions are a mixture. They are not a pure substance because they're a mixture. They do not have a specific ratio. They are separated physically. And solutions can be separated by distillation. And we'll go through what that is in a couple slides here. If you try and shine light through a solution, it is going to shine through. The mixture will not separate on its own. It can be separated through distillation, but it won't separate naturally. The 2 parts of a solution would be solute and solvent. And the equation for concentration is the solute divided by the solvent. And solubility is the ability of a solute to dissolve in a solvent. Okay, the next one we had is suspension. Suspensions are a mixture. They are not a pure substance. They do not have a specific ratio. They are separated physically. And suspensions can be separated by using filters because their particles tend to be pretty large. Light will always be blocked. If you try and shine a flashlight through, you should be able to see the particles inside, and it will separate on its own. And it has fairly large particles. Most of the time you can see those with your eyes. And a colloid is still a mixture. It is not a pure substance. It does not have a specific ratio. It's separated physically. So right now what you should have noticed is that solutions, suspensions, and colloids are all mixtures. They're not pure substances. They all don't have a ratio, and they're all separated physically. Colloids can be separated a couple different ways. Kind of depends on what you're working with. So for instance, blood is a colloid because it doesn't separate on its own, but it blocks light. So you could use a centrifuge, or you could use distillation. Obviously you'd use a centrifuge for blood because you don't want to boil blood, or you'd end up killing all the cells inside. In a colloid, light will be blocked. The mixture does not separate on its own, and it tends to have, you could either say large or medium. The particles aren't very small. The smallest particles would be in a solution because you cannot see them and they don't block light. The 4 ways to separate a mixture and what are they used for. The first one we talked about was distillation. That separates based on boiling point. So generally used to separate 2 liquids. It can also be used to separate a solid and a liquid as long as they have 2 different boiling points. Centrifuge spins and separates based on density. A magnet can be used to separate metals from nonmetals. And the last one we talked about was a filter. And a filter separates based on size. So it's going to separate the large pieces from the smaller pieces. Most often we use that to separate one solid from another liquid, but it can also be used to separate 2 solids as long as one of those solids is very, very small. Okay. The first picture is an element, and you know it's an element because there's only one circle each. They're not bonded together. You also know it's an element because it's pure. So it's an element because it's pure, and there's only one circle on its own. The next one is a compound because you know it's pure. They're all the same, but it's not an element because you have 2 elements stuck together. The next one is not pure, which immediately makes it a mixture because all of those do not look exactly the same. So for this one, we're sorting out the difference between compounds and mixtures and comparing. It says A says properties of the new substance change, so that would be a compound because it's a chemical change. B says you have at least 2 elements, that is both compounds and mixtures, that's why we put it in the middle. C says properties of each substance do not change, that would be a mixture because that's a physical change. Distillation, filtration, centrifuge, and magnet are all methods used to separate mixtures. Not chemically combined is also a mixture. Chemically combined is a compound. Easy to separate should be a mixture, which is G. No specific ratio is also a mixture. Hard to separate would be a compound. There's only 2 ways, heat and electric currents. We're also going to put K over here. Can be separated. Both of these can be separated. Some are just a little bit more difficult than others. And the last one you have is L. Specific ratio of elements should be compounds. The first picture is a mixture because it's not pure. The second picture would be a compound because you have at least 2 elements stuck together and it's pure. The second one is also a compound because you have two elements bonded together and it's pure. Okay, if we have H2O, your way to tell if it's an element, compound, or mixture is 1. How many elements are there? There's 2 capital letters, which would tell us that it's a compound. The next one we have just H. If there's only 1 capital letter, it is only an element. The next one you have NaCl. You have 2 capital letters, that makes it a compound. And then the last one is pointing at everything inside the beaker. You have H2O, you have hydrogen, and you have NaCl. So you have 3 different things. It's not pure, which makes that a mixture. Okay, your easy way to tell the difference between a solute, a solvent, and a solution is that solute has the least amount of letters. It should have the smallest amount. Solvent should be the medium amount, and the solution should be everything, so the largest amount. So if you're stuck on the test, you can count the letters. Solute only has 6 letters, solvent has 7, solution has 8. So you can go in order of the amount. So in the first picture here, that little green pile would be the solute because it has the smallest amount. And the next biggest would be the blue liquid, which is the solvent. And when you mix those two together, you're going to get the solution, which is a type of mixture. Okay, same from the bottom. I'm going to start with the solute, smallest amount. That's the 10 grams. 100 grams would be the solvent. And solute plus solvent equals solution. And in the picture on the right, the orange looks a lot smaller than the blue, so I'm going to say that's a solute. The blue is the solvent, and the blue and the orange put together would make up the solution. When we calculate concentration, you're going to take grams of solute divided by solvent. So your smaller number should always be going first in your equation. So it says, what is the concentration of a solution that is 35 grams of salt dissolved in 175 milliliters of water? So I know that the salt is my solute because it has a smaller number. So I'm going to say concentration equals 35 grams divided by 175 milliliters. I'm just going to give you 0.2 grams per milliliter. Okay, in the next problem we have what is the concentration of solution A that is 55 grams of sugar dissolved in 500 milliliters of water. So the exact same equation, we have concentration equals solute divided by solvent. Take the smaller number first because that is your solute. So we'd have 55 grams divided by 500 milliliters. And 55 divided by 500 gives you 0.11 grams per milliliter. The difference between a dilute solution and a concentrated solution is dilute should have a low number of solutes and concentrated should have high. So you look at the pictures, the one on the left has the least amount of solute, that would be dilute. The one on the right has the most amount of solute, so that would be concentrated. When you look at the graph, the trend for solutions and solubility is that solubility increases as temperature increases. So the hotter a liquid is, the more solute you can actually fit in there, and it will disappear. If you cool it down, some of that solute is going to settle out. It's not going to be able to completely dissolve. And we're filling in the table with yes or no here. So solution. Is a solution pure? No. Does it separate? No. Does it block light? No. Can you separate it with a filter? No, because it's not large enough particles. You can separate it with distillation. Cannot separate it with a centrifuge. Suspensions are not pure. They will separate. You can see the two distinct layers. It will block light. You can separate it with a filter. You could also separate it with distillation. You could also separate it with a centrifuge. Colloids are not pure. They will not separate. They will block light. They will not separate using a filter. They will separate using distillation, and some will separate with a centrifuge. Not all, but some. And that's all the review questions for our elements, compounds, mixtures unit.